Thanks. So I'm Ben Kehoe. I'm from iRobot. I'm a cloud robotics research scientist there and an AWS serverless hero. I'm on Twitter. You can see it there. And yeah, so we make the Roomba. And in 2015, we released our first connected product, the Roomba 980. And something that's important to keep in mind is that we go back to 1990. We have a long history of making robots. We have a history of making connected robots. You know, we had telepresence, we had networked robots, and then some like really creepy dolls and things. But we didn't have a history of scalable cloud connected robots. And so Roomba was at scale, right? We sell millions of Roombas a year, and then we wanted to connect them. Oh, yep.
Make it a little louder. Yeah, just kind of shout into it, I guess. There we go.
All right. So apparently I need to be louder. Can you hear me? All the way at the back? All right. Okay. So yeah, so we had a business that was at scale, and we wanted to connect these. And prior to launch, we had decided on a full solution IoT cloud provider, and had realized even before launch that that wasn't really the direction we needed to go. They didn't have the scalability that we needed or the extensibility. So we wanted to bring that in-house. And we decided to build the application on AWS, and as our connectivity layer to use AWS IoT. And this was 2015. Lambda was very new. AWS Lambda and sort of the whole serverless movement was very nascent. But we looked at it and we said, given the suite of services on AWS, we think we can build this without having to run any servers. AWS IoT is, transparently scales. There's no knobs you have to turn for it. There's no servers you have to run. And that worked great. We were able to scale without, to leapfrog having to learn scalable cloud technology. That's not something that we do. And so instead, we just operate our connected products and build features for them. And so we're connected across our entire line. And then just a couple of weeks ago, we released the next generation of robots, the i7, which sort of extends our mapping capabilities and brings the features that we can offer through our cloud connectivity to the next level. And so we're able to continue to extend that and bring this into the smart home, right? Today you can ask Alexa to tell Roomba to give the cat a ride. That's one of the Easter eggs in the skill. We work with Google Home. We do all of these things. And as the robot maps your home to be able to clean better, it can also provide that as part of your smart home user experience to improve that. That's what we do as a business. But to be able to do that, we need to provide these features on the cloud. And to do that, we've gone all in on serverless. And it's worth the trouble. It's a lot of work in some sense to get to the point where you can be all in. But by the end of this, I'm hoping to convince you that it's worth it and provide you with a set of recommendations on how to approach that. As with all of software, the hardest part of this process is people. So as a business, we are a device company, right? We're a cloud-connected device company, but we're not a cloud technology company, right? We're not in the business of developing technology for the cloud. We're in the business of creating features for our users that are enabled by the cloud, and that's not the same thing. What we want to ship is features. We don't want to ship technology. So where this starts is asking yourself what you do as a business, right? What is the thing that you are delivering to your customers? And for some people, the answer is technology, especially like the AWS partner ecosystem is delivering cloud technology to their customers. But for someone like iRobot, as an end user business, right, our customers want their houses to be clean without them having to think about it. And everything we do is focused around that. So you ask yourself what you do as a business and what differentiates you. How are you different from your competitors? For us, it's the quality of our mapping, it's the quality of our products. They last a long time. They're modular. You can replace the wheels in them and stuff as they get older, so people have Roombas for years and years and years. Our connected user experience, so how people interact with the robots when they have to. And for each of those things, ask why you're doing it if it's not a differentiator, right? If there's some work that you're doing that all of your competitors are doing too, the same way, why are you doing that work? And you want to do this recursively, right? You want to look at, okay, I'm doing this as a differentiator, but inside of it, there's a lot of things that I don't need to be doing. Hint, one of those things is running servers. And the fundamental point is that you shouldn't have to solve technology problems before you can solve your business problems. You want to be solving your business problems directly without saying, okay, well, to ship this feature, I need to figure out this technology first, or I need to develop some technology, unless that technology is a differentiator, right? We have a lot of people who work on robotics and robot mapping and cleaning technology, right? Those are all differentiators for us, and those are technologies that we own and want to invest in. Operations for clusters of cloud VMs or containers, not something we want to do. And so at its heart, serverless is about focus, right? It's about caring about what you're doing and keeping your eyes on the ball, right? And so how do we focus? Your attention is limited. You only have so many resources, and you have to allocate them to the things that you think are important, and that is always going to involve trade-offs. So how can you pay less attention to things that are undifferentiated heavy lifting? You get someone else to do it. You find someone for whom it isn't undifferentiated heavy lifting, right? For AWS or AWS partners, those cloud technology things that are the differentiator for them, that are their focus, they should be good at those things, and you should be able to pay them to do that thing for you so that you don't have to care about it. And so this is all about using managed services. And this gets to a misconception about serverless, that it's often equated with AWS Lambda on AWS or other functions as a service. But this really misses the bigger picture of what serverless is about in technology terms, and it also misses the smaller picture. So the big picture is about ephemeral compute. Sorry, this is the smaller picture. These slides are slightly misordered. So attachment is suffering, at least for cloud computing. When we started out, we treated servers like pets. They had names. We took care of them when they got sick. We repaired them. We healed them. And when we moved to the cloud, they told us that we need to treat servers like cattle, where they have IDs, you have a lot of them, and you don't really care about any individual one. If it gets sick, you just replace it, and that's all fine. I like to say that when you're serverless, you treat servers like roaches. You stamp them out wherever they exist. But this isn't actually really true. The real point is that your compute should be like mayflies, right? Mayflies live for 24 hours. Their entire life cycle happens in a single day. And the more that you can move your compute to being ephemeral, the less you have to worry about it, because whatever's happening will be over soon, and will start again, and you can do something different the next time. And so so this applies to something like functions as a service, like AWS Lambda. It only runs for 5 minutes. Everything you do inside Lambda function needs to happen in 5 minutes or less. That's ephemeral, and there are good reasons for that. And this gets to why serverless compute isn't just platform as a service, right? People ask, what's the difference between it? Because managed services have been around forever. S3, for example, serverless object storage. It's been around since the beginning of AWS. Your business logic has to go somewhere. So you're using managed services for things, and then you need to bring your code into it. And managed rules engines exist, right? If you want managed business logic, You can get rules engines that help you do that without writing code. But you always eventually grow out of it. There's something that you can't do inside any given rules engine. So then you have to code something. And this is where ephemeral compute comes into the change between platform as a service and serverless. Ephemeral compute says, this compute is only going to run so long, and then the resources that it needs go away. And that allows the provider to manage the underlying compute. And this is where serverless isn't just functions as a service. It's managed services in the big picture. That's more important than your compute. But in the small picture, it's more than just functions as a service, because functions are temporally ephemeral. But if you have finite input to process, that's also ephemeral. A batch job is fundamentally ephemeral, because as soon as you're finished with your input, you can go away, and whatever's underlying it can be managed by the provider. So a service like AWS Batch is sort of on the serverless spectrum. So what you want to do when you're serverless is use and abuse managed services wherever you can. Get them to fit your needs, and avoid writing code wherever possible, right? Choose someone else to do something if there's someone to do it, rather than taking on the responsibility for that if it doesn't differentiate you. And so this is where the term serviceful is a better moniker for what gets called serverless. Because in the big picture, your managed compute is a small part of the overall picture. But that's what glues it all together, because that's what you differentiate yourself with, your business logic, right? And that should be ephemeral compute, of which functions as a service, like AWS Lambda, is one example. So when we get into sort of a more technical definition, we get this service-full ephemeral compute. You want your resources billed to approach your resources used, so that you're not paying for idle. And you want a smaller and more abstract control plane. You don't want to have to tune a lot of knobs to get it to work out of the box. Having knobs can be useful when you're a more advanced user and you want to sort of get more performance out of it. But in general, you don't want to have to set up something complicated and manage something complicated if you don't want to. But more important than the what is the why, right? That you get lower cost because you're not being billed for resources you're not using. You get lower operations burden, right? We have a lot of connected robots, and we run that with single-digit FTE for operations. The system just runs itself from our perspective, because all of that operations has been pushed onto the providers of the managed services that we're using. This gives us a faster time to market, because we're just gluing things together. We're integrating, we're writing the business logic, we're operating in our business problem space rather than in the technology space underlying it. And that allows us to do the most important thing, which is focus on our business value. So the long form of what you want to do with serverless is use existing managed services in preference to building and or hosting your own solution. So even if it's not something you built, but it's a piece of software or technology that you bring on board and run and own yourself, you don't want to do that even when the services don't quite meet your requirements. So if it's that kind of 80-20 situation where if you find something that meets 80% of your needs for 20% of the effort, you really have to look at, is it worth getting that extra 20%? What are the marginal cost of increasing the fit? And often when you look at a managed service versus doing it yourself, it's a huge marginal cost to improve beyond that managed service level of functionality. And it's usually not 80-20, it's 90-10 or 95-5, right? That it's almost everything you need, and you can usually work around it. So the pithy one is that it's like masonry, right? You're building a wall. Functions are just the mortar. They glue everything together, but the load-bearing part of it is the bricks, and you want to buy those. You don't want to be, mining your own clay or operating a kiln. So going back to how do we focus, right? There's a thing called Conways Law. And Conway's Law, that's the Conway's Game of Life, which is a different Conway, but it's a nice illustration, so it's there. So Conway's Law says that the communication patterns in your software are going to match communication patterns in your organization, right? That if you have two groups working together, you're going to end up with an API in between. And that's just because that's how it will evolve naturally for your organization to function in the way that it's set up. So when you're moving to serverless and you're thinking about this, you want to turn this around. What you want to do in your software has to be first manifested in your organization. So serverless is serviceful, right? This is the big change in serverless, is saying, I want to outsource everything I possibly can to manage services. And so we need to figure out, what does this actually mean from an organizational perspective that will allow us to enable using ephemeral compute and managed services for everything that we want to do. And this is a cultural problem. Again, the hardest part of software is always people, and the hardest part of serverless is also people, right? It's changing the mindset to how you build and deliver solutions for your business problems. And it's an exercise in trust, right? You're giving up control of something to have it be provided by an external provider. And that's hard, right? So you only know what your provider tells you in terms of their architecture, in terms of their security, their performance, and what metrics they give you to have observability into that system. And you can't just make changes to it, right? It's not a piece of technology you own, so you don't get to go in and make changes to it. You have to accept that today, it is what it is. Now, hopefully working with a provider, you get to say, this is my pain point, and I would like it to be different in the future. And this is, there's a hashtag on Twitter, AWS wishlist, which people use to say, these are the things that don't work for me. If you have support, you go through your account team as well, those kind of things. And AWS is very good about listening to customers and taking that feedback on board. Doesn't mean it changes quickly, right? Pain point for AWS Lambda from the beginning was the lack of an SQS integration. So I want to queue things up and I want Lambda to take care of that for me. That got delivered this year, but there's a 3-year stretch where there were workarounds, but it wasn't something that was supported by AWS, even though everyone was asking for it from the very beginning. The scariest thing is that you may not be able to remediate a provider's outage. An incident with a provider may cause you to be unresponsive to your customers. And that's a scary thought. But you really need to think about if you were taking on that responsibility, sure, you might be able to remediate it. But A, would those incidents happen more often because you are worse at doing that because it's not what you do as a business? And would you be as good at remediating it in a timely fashion? When again, it's not a direct revenue providing part of your business. So it's scary, right? You feel that you no longer own your own destiny, and that's uncomfortable. That's a fact of life, that it just feels uncomfortable. And it's something that, to be serverless, you really need to learn to be to accept that discomfort. It doesn't go away. It just becomes a part of what you're accepting in sort of your risk management strategy. And you rely on many, many trusted providers to operate your business, right? The electric company is one of them. And you may have a remediation strategy, like generators, to provide backups. You probably don't have generators that run everything in your business, right? The generators keep your servers up and running, but the lights over, HR will go out because you've looked at the risk and the cost-benefit trade-offs of a power outage, and you've decided what things you need to remediate and what you haven't. You also want to remember that trust is a journey, that when you engage with a provider, your trust may be low and you want more assurances, but you can work and develop a relationship there that allows you to have more trust. And so for developers, right, and engineers were tinkerers. And handing off something to an opaque managed service is hard. We like to know how things work. We like to own it. We like to know that everything underneath is something that we control and we can understand. And so saying, okay, well, everything behind this API, I only have vague understandings of how it works, but even though I know exactly what it does. And that's also an uncomfortable place to be. But this is kind of like, with modern cars. Modern cars are hard for an owner to maintain themselves, right? They have complicated electronics in it that are not really accessible to the average consumer, the average do-it-yourselfer even. And so they often have to be brought in to be maintained rather than being repairable, by the owner. And people complain about this. But if you look at cars now versus, say, 20 years ago, when they were more able to be tinkered with, more able to be repaired at home, they run better now. And the amount of time that they are out of service, even though they have to be brought in during those times, is lower than when they were more maintainable by the average user. And that's the trade-off that is being made, is saying the car's purpose is to get you from point A to point B, and uptime is the most important metric of that. And given that, we want it to run better, even though it may not be as maintainable by the user themselves. And this is the trade-off that we're making in serverless, right? That sure, we may not be able to take action on the technologies that we're using, but it works better overall and allows us to deliver our end goal much better. So, this is a symptom of not invented here syndrome, which is, whenever you run into a build versus buy scenario, a common organizational pattern is to say, well, it wasn't invented here, we don't trust it, so we're not going to use it. And it's easy to go from, okay, well, we shouldn't build it ourselves, right? Once you get over that hurdle, you run into, well, there's an open source project that does this. And people contribute to it, we can trust it. So let's use that. Serverless is about moving from there to saying, well, that's still something we host. And we still own it. We're still doing that build step in operations, as well as sort of development around configuration and things like that. And that's the same not invented here attitude of, oh, well, this is something we want to own. We want to run it ourselves. And so shifting again to managed services is the next step of eliminating not invented here. And Procter & Gamble worked very hard on this in their organization to eliminate not invented here. And they came up with a kind of cheesy phrase for it called profoundly found elsewhere. And there's this art installation that I saw on the internet, be afraid of the enormity of the possible. And I like this phrase because it's really about that when you encounter a problem and you're thinking about solving it yourself, whether that means building a piece of technology or running a piece of technology that you're buying or obtaining, it's almost always more complex than your initial estimation. And there's often hidden complexities that you don't think about. For example, developers especially, but people in general, devalue their own time, right? And okay, so it's cheaper from a cloud bill perspective, but how much people's time is being spent on it to reduce the cloud bill is often not thought about. And so this is, sort of turning this around to say, how do we approach something with, how much does that cost us to do? And what am I giving up by working on this instead? Right? What is my opportunity cost to owning this piece of technology? And in that sense, restrictions are good, right? That when you restrict, you reduce what's possible, and you reduce that hidden complexity. And in this sense, serverless is sort of a minimalist philosophy, right? Don't own what you don't have to. So there are a lot of distractions from going serverless, and I'll talk about those for a little bit. So first, it's a terrible name. Nobody likes it. Nobody says, oh, serverless, it's named exactly what it should be. But we're stuck with it. Like, it's not going to change, and so everyone needs to get over it. And it will become meaningless like cloud. At the recent Google Next conference, they slapped the serverless label over everything they released. And so it's more important to focus on the aspects of a particular solution or approach to figure out, how worthwhile it is in this nebulous serverlessness. The primary metric for that for me is how managed is it? How much work do I have to do to use it? And then the secondary metric is, okay, how closely does my bill match my usage? Do I pay up front for a bunch of things? And even if I don't use it, I still get billed for it? Sometimes that can be okay. There can be, if it's completely managed and I don't have to deal with anything operationally, but my cost is, not closely tied to usage, that may still be a very valid option. So the other thing is calling things serverless by sort of semantics, because there are two types of servers, right? There are the infrastructure notion of a server, a box that's running somewhere, a VM usually. And then there's and that's sort of an operational concern. The development concern is application servers like Node.js, Tomcat, things like that are running code. And those are both servers. And you're really only fully serverless when neither of those are in the picture. When you don't get me wrong, getting rid of one or the other is useful and makes you more serverless, but it's not enough to say, okay, well, we've gotten rid of one of them, we're good. And so this is, if you have a container that's active when it's not handling data, that's a server. And so when you look at something like, hosted functions as a service, right? There are projects out there, open source projects, which give you a very nice interface to create your own functions as a service stack. That's not serverless. You're still running that technology. You're still running the servers that run those functions. You're still owning the operations of that technology. Now, if you're a giant organization, right? Amazon.com uses AWS Lambda, and they're serverless. That's a serverless use of AWS Lambda, even though it's the same company. In some sense, it's on-prem, right? It's all owned by the same company. But it isn't really any different from if it was a different company. And if your organization is large enough and the developers that are using a hosted functions as a service on-prem installation, that development team is serverless. Your organization as a whole isn't, but that can be okay, right? It's at least a step in a good direction for that development team especially. So let's talk about Kubernetes. So Kubernetes on managed virtual machines is serverless for the Kubernetes admins, right? EKS on AWS, GKE on Google, right? That the Kubernetes admins don't have to worry about what's going on underneath. And this is, Knative is mostly this for on-prem if you have somebody else worrying about the VMs. However, you still have Kubernetes admin to do. And that's admin that you're taking on, a technology that you're taking on, work that you're doing that probably doesn't differentiate you. You also have to manage whatever's running on Kubernetes. That doesn't go away even if someone else was doing the Kubernetes admin for you, right? If you're running hosted software on top, that's things you own. So again, if you have functions as a service running on top, you're operating it and maintaining that. And that's something that probably doesn't differentiate you. So the other huge distraction when it comes to serverless is people talking about vendor lock-in. And there are two kinds of multi-cloud strategies that people talk about, and they're important to differentiate. The first is people worrying about, I'm going to be beholden by using all these managed services. I'm going to be beholden to a single cloud provider, and that's going to be bad for me. The other is I want to pick and choose the best managed services from wherever they exist. In isolation, I want to say, I think Google has the best machine learning, and I think AWS has the best functions as a service, and I think Azure has, something else. And so I'm going to go use those, and I'm going to use this small third-party provider for my authentication, something like that. So I'll talk about those two separately. So the first is vendor lock-in, and the truth is that it's not a real threat. People are really worried about this, but there's a very easy. So first, the remediation here is to build an abstraction layer over your cloud provider, right? To say, I'm going to write a layer that says, I can use whatever NoSQL database I want, and my code will just work. The cost of that remediation is that you are not taking full advantage of the unique features of your provider's offerings. So, if you're running on DynamoDB, but with the abstraction layer, you can't use secondary indices, right? And that's hamstringing yourself for a possible future change that you might want to make. But it's not a future change that you'll want to make. And to talk about why, I want to talk about cow tipping. So cow tipping is this purported activity in rural areas where people go out, possibly at night, and push cows over, and they fall over on their side. And it's an urban legend for a long time. People debated about whether it was possible or not, but there's an easy proof that it's not possible to tip a cow. And that is, you go on YouTube, and you type cow tipping, and there are no videos of people successfully tipping over cows. If it was possible, somebody would have put a video of it on YouTube. That's just the truth. If you look at people talking about multi-cloud, there's a lot of people out there talking about that they want it, how they do it, things like that. There's nobody out there saying, we didn't go multi-cloud, and it really came back to bite us. Or we went multi-cloud, and here's how much money it saved us. Nobody's out there saying that. You even look at a company like Spotify, which picked up from AWS and moved to Google. They're not talking about that they learned their lesson. They're all in on their new provider, right? They understand that any provider that you're on, you want to take full advantage of. And movement costs, right? If you're on a different provider and you're looking at AWS and you think, I'm going to be all in on AWS and that's a bad thing. No, you want to be all in with what you're using to extract the value out of it. The cost of moving and the risk of having to move or wanting to move is low relative to the value that you extract out of the provider while you're using them. So there's another thing that helps remediate this, because as much as I can tell you that multi-cloud is not a real threat, people still worry about it. And so there's now a project called Cloud Events from the Cloud Native Computing Foundation. And I'm a big fan of this, because this is a specification for interchange of events between cloud providers. And all the tier 1 providers are on board, and it's progressing. That's great. And I'm a big fan of this, even though I think it will not be used very much. And the reason why is because for people who are worried about multi-cloud, it provides an outlet. It says, okay, well, if I get sick of my cloud provider, I can start shipping my events somewhere else and work on a different provider. Like I said, it's not going to happen that much. It's very rare that people find that they really need to move, especially with sort of today's tier 1 cloud providers, where they're much more transparent in how they price things and how they operate, as compared with sort of traditional enterprise software vendors. And so Cloud Events provides a security blanket to allow people to feel more secure, feel less vulnerable about being locked into their cloud provider while not actually adding any overhead to how they operate on a daily basis. It's sort of a safety valve that nobody's ever going to pull, but will make so many people feel better that it's there. So shifting back to the other kind of multi-cloud that people want. They say, I want to look for the best service anywhere and pull those together to do something. And that's possible. The problem with it is gravity. So data gravity is a big one, right? If I want to combine something between AWS with some other provider, and I got to ship a lot of data to do it, that's going to cost me a bunch relative to everything being free within AWS. But with serverless, you have an added overhead of integration gravity. Things work better. I can trigger Lambda more easily off of any AWS service than I can, some other function or a hosted cloud function. And cloud events will help with that, but it adds another step in between there that's just more overhead. And so you got to be pragmatic about it. You got to look at what your total cost of ownership is and say, is the narrow view of how much more performant this service that I'm looking at is that worth the broader cost of higher overhead and integration and possibly operations? Because when you're all in on one provider, your operations are simpler because you only have one method of getting metrics that you have to worry about. As soon as you're using multiple providers, you have that information coming in different ways. And that's just more things to work with. But it can be worth it. Just make sure that you're looking at the big picture. So SLAs come up sometimes in this and say, oh, this service doesn't have an SLA, and therefore I don't feel comfortable that it's going to perform well or at the rate that it's nominally said to work at. And the answer is an SLA should not, as a developer, make you feel more comfortable. Because an SLA is not a performance guarantee. It's a financial guarantee. It says that if it's not living up to this level of service, you get money back. If it's not living up to that level of service, you are still, if you're relying on that to provide something to your customers, you won't be providing that to your customers, and you have to own that to your customers, right? You will get money back, and so in that sense, it's insurance, right? And that price is baked into the premium. Now, that can be worth it. That's more of a CIO question than a developer question. But you need to, again, sort of look at the technical constraints of, okay, we expect it to be at this, but what if it's not? And if it's not at that level, that's very important to us. So we have to have remediation steps in there. Or that level is good enough. We will trust that it will be at that. And if it's less than that, we'll sort of live with the results. So how do you adopt a serverless mindset? How do you get around these distractions and work at that level where all you want to do is solve business problems, not technical problems? So Elsa says it best. You got to let it go, right? And a good gateway drug for this is events. Events, by their very nature, are ephemeral, right? They exist at a moment in time. And they're a very natural fit for serverless architectures. Though you can use them, you can be entirely event-driven on very traditional architectures. But if you move in that direction, it's going to be easier to later replace that with serverless versions because it's a more natural fit. If you have things that rely on long-running processes, on servers that are keeping connections open for long periods of time, that's going to be harder. As an example, right, SQL databases tend to require traditional like JDBC connections that expect a small number of long-lived connections that share a lot of requests through them, right? That's a very server-oriented type of connection. NoSQL databases tend to be more HTTP-based, stateless, or expect a lot of concurrent connections to that database. With functions as a service, where you have an individual process, right, an individual container that handles each request, traditional database connections don't work well. They tend to choke the database when you scale up. So if you're looking at, I'm building a server-based thing, but I want to make this serverless later, that's where you want to look at, well, maybe orienting this towards something that I can shift into a managed service later that fits both on the database side and the compute side with a managed service called by functions as a service is the way to go. So that's sort of a long-term ulterior motive that you can bring to architecture discussions. You always got to stay focused on total cost of ownership, right? Serverless is as much about economics as it is about technology. You need a level-headed assessment of risks, right? That's where the vendor lock-in piece comes in. And you want a full accounting of costs, right? That it's not just how much does this cost me, from my provider. You want to look at how much developer time is this going to take between different solutions. How much is my operations bill going to be, right? That is important, but your operations time is important too, right? That your operations salary should be coming out of the same budget as your cloud bill because there's a trade-off there, right? You can do things that are more server-based, but it's going to take more people to run it, right? If we, and this is a point I'll bring up later again, is that, for us, we use 30 different AWS services in production, but none of them are EC2, and we've got no Docker running. So it's 100% serverless. And we run this with, a couple of people. If we added just one container-based thing into that mix, we have a large step change in the amount of operations we have to do. And so we avoid that. We're avoiding that as long as possible. Eventually, we'll get to a point where we need it somewhere, and we'll do it at that point. But because that trade-off of, okay, well, this Lambda-based contraption is a little more complicated architecturally and maybe costs more than a container-based solution, but it runs itself. That's a trade-off that we can make. Similar, you look at something like SageMaker. It's like a 30% premium over the EC2 cost, and if you're able to run your deep learning jobs on Spot Fleet, the difference is pretty large. But that only helps if your developer time is not eaten up by managing your own learning infrastructure. And so you really want to look at that of, both in terms of time to market, but also cost of how much am I actually paying for the whole thing, not just how much does this cost me at the end of a month, coming from AWS. So total cost of ownership example, provider outages, what's the impact? When it's down, are you completely down to your customers? Is it degraded? Is that okay? What is your user experience and what trade-offs do you have to make? What's the likelihood of that happening? Is this something that happens once a year for an hour? Is it something that happens once a month for 5 minutes, right? What's the cost of implementing a remediation strategy? And that's the really biggest thing is, okay, in monetary terms, what is the impact of an outage? So then you turn that into what's the total cost of ownership to avoid relying on a provider for this. If you say, okay, well, the remediation strategy is too costly to rely on the provider and have some, say multi-region solution. Okay, well, I want to move from a multi-region serverless solution to a multi-AZ server solution. Then you got to bring in your operations cost into there as well to make sure that you're adequately understanding your total cost. And then fundamentally, culturally, you want to encourage a focus on business value. So you want to connect your developers to the business value that they're creating. Your team metrics should reflect this, right? You want to be measuring them not on how well they're developing technology, but how well they're creating value for the business. And you want them to be excited about that. You want them to be excited about features, right? You want them to be close to the features that they're creating rather than at a far remove to say, I'm developing a database solution so that someone else can create a feature. Well, if that's a managed service, those developers can be freed up to work on user-facing features. And as always, this is a cultural thing, right? You need a culture that cares about features and not about technologies, right? That when people are looking at what they want to do, it's, I want to create something that our users are going to use, and not, I want to work on an interesting technology that's, for esoteric reasons. You have to be okay with Rube Goldberg machines when you're serverless. As you are building them for managed services, which, again, you have to accept the services as they are and not as you would like them to be, wiring them together becomes complicated because you have to look for the functionality you want, and you can't combine that all into one server as maybe you could before. So you start wiring things together, and what used to be a call graph in your software becomes your component graph in infrastructure. And so you need to be comfortable with that. You need to be aware of it. And that's one of the rough edges of serverless, is tools don't understand infrastructure graphs that are as complex and that are as intermingled with code as a bunch, 30 AWS services with bits of Lambda strewn all over the place. That's getting better. It has a long way to go. And this is where, if one provider doesn't sell a parrot, you go buy it from somebody who does, and you wire it together, if that parrot is needed. You want everything to be Legos, right? You got a big bin of services, and you can pick and choose them, and they all just plug together. But it's not always that way, even from the same provider. This is Lambda and SQUS, that they didn't work together for a very long time. And so you find workarounds. For Lambda, that meant having a periodic CloudWatch event that would trigger a Lambda to go read from the queue. That was a pattern that worked for a very long time and still works, but now you can connect it directly to Lambda. And so when you find these pieces where it's like, okay, well, I want these two things to work together, but they don't, what am I going to do? Well, I could just replace that thing that I'm trying to do with something that I've put on a server, or you can duct tape it together. And serverless is really often an exercise in, again, using and abusing managed services. So using them in ways that they're not out of the box recommending you to use them or establishing as a best practice pattern, but you're finding ways of saying, well, I can take Lambda and I can work around this to get the thing that I want, while being vocal about this is a use case that should be solved with these services, right? Because it always gets better over time. So going all in on serverless, right? It's extraordinarily powerful. And this difference, as I mentioned, between all in on serverless and mostly serverless is huge for operations. For development, less so, right? A mature team running on containerized infrastructure can be, as productive as, a team that's just fully serverless and mature at that. But for operations, the difference is night and day. You need so many fewer people, and the complexity of the operations that you're taking on is so much smaller. And when you start to introduce even just small elements of server-based traditional architecture, you get so much of that operations burden back immediately. So it's not easy, and I'm not here to tell you that it's easy. It is getting easier, but it is worth it, right? And this is where iRobot, Chris called us a small company, and we are actually a surprisingly small company for the scale of things that we do, and especially from the cloud team being under 20 people and a couple of operations people to do all of these things that we do, because we just ship features, because we're not bogged down in trying to solve technology problems for the cloud. We can free up those resources in our engineering organization to work on the complex robotics problems that we want to solve. So you may be skeptical that all of these hard things that I've discussed are obstacles that can be overcome, or that it's worth it to overcome them, and that all of the rough edges are worth dealing with. But if you go back to the what and the why of serverless, right? The what doesn't actually really matter, right? Sure, that's what it is, but when we talk about why and the benefits that you gain, and the fact that at heart, you can focus on your business value. As as a CIO or a VP of engineering, that should be attractive. But as a developer, you want to be looking at this and saying, yeah, why aren't I more connected to delivering exactly what the business wants? Why am I not more connected to our users, right? And serverless helps you do that. Serverless helps you free up time to focus on the things that really matter. But it's a process that takes a while and a lot of understanding to realize that the control that you need is something that you have to let go. So it's only going to get easier, right? Over time, all of these things improve. AWS especially is extremely good at listening to customer feedback. There are a lot of things that the serverless folks, especially in the developer evangelists and things, are out there talking to customers and understanding where the pain points are. This is where Amplify comes in. This is where AppSync, people really love it, and it's one of those things that just sort of runs itself. It just works, and enables people to focus on the goals that they're trying to accomplish rather than the technologies that they need to run. With that, I will take questions. Yeah.
So if you go full serverless, you eliminate the vast majority of your operations team. What did you guys do, or do you anticipate would happen for those employees?
So the question is, what happens to your existing operations team? Now for us, so a unique thing about iRobot, right, was our business was at scale, but did not involve a scaled cloud component. And so we were building greenfield. And so we didn't have an operations team, essentially. We were building one up. And so I think the part of the thing is that with serverless, I was talking with Chris about this earlier, that the amount of code that you're writing goes down. And the amount of infrastructure you're managing goes up because you're using more managed services, right? You look at somebody like, say, Netflix, right? The primary service that they use is EC2, right? They run a lot of EC2 and probably not a lot of other services. So their operations, AWS-wise, are looking at just one service. When you go to a serverless approach where you're using managed services for all these things, you start to use all sorts of different services, and like your cloud formation becomes very complicated. And so I think there's a lot of space for operations folks to become, that you want your developers and your operations folks to sort of be one and the same, right? Because especially with serverless, as your infrastructure and your code merge more and more, there isn't a clear split between understanding what's good from the application perspective and what's good from the operations perspective. And so you need those people to be the same. And so depending on the people, right, it may just be that those two teams should just be the same, and then you have those resources to apply towards it. Yes?
Back in the day that I was doing hands-on software development, it was a rare organization that had adequate separation for development, test, and production, let alone any other environments. I'm predisposed to think that getting an organization to actually be well-disciplined regarding those separation environments can be a much easier proposition with this.
So the question is about separating your production and test and development environments. And right, there's that joke about everyone has a test environment. Some people are lucky enough to have it be different from their production environment. So when you move towards more provider-based infrastructure, you end up needing to use more infrastructure as code tools. It becomes harder to proceed in ways that are not replicable. So in other words, if you have to set everything up with CloudFormation anyway, or with the serverless framework, turning it into CloudFormation, something like that, that's going to be able to be applied across different AWS accounts, for example. And so it becomes a little more portable. So you still need discipline to do it, to say, all right, these Lambda functions, this is the production AWS account, and we're not going to deploy Lambda functions that aren't production Lambda functions in that account. But the nature of a very managed service heavy infrastructure means that you're going down routes that aren't, you can't SSH into a Lambda function to make it do anything, right? So it's not like you can have very custom tweaked environments that end up making it hard to replicate across different places. You certainly can, right? If you go in and you set everything up through the console, then how do you get that in 2 different places? But the tools for deployment and the things that make development easy tend to go the route of putting it into config as code tools. So I'm hopeful that it'll make it easier. But it's still, again, people are the hardest part, right? You got to convince the people that it's a worthwhile thing to care about. And making it easier means you don't have to get them to care as much. The bar for caring is lower if it's an easier thing to do. Is someone else back in the, yeah?
I think it's a similar question, but can you talk about how serverless affects your ability to quickly do upgrades and deployment? And I understand that if a lot of your stuff is managed, you don't have to worry about that. Well, that's the problem. But
Yeah. So
convincing management that you'll have to deploy this to Lambda, and it's blue that spreads all over the place and all the time.
So the question is about deployment and convincing people that deployment is easy. Deployment is actually hard in serverless. A lot of the things that are mature technologies for traditional architectures around blue-green deployments are not really possible in serverless today. There's a lot of, I can take one Lambda function and seamlessly update it and roll it back if there's a problem. There isn't a lot of stuff around, I want to take a constellation of Lambda and services and IAM policies. I recently gave a talk at Serverless Conf San Francisco about exactly this topic. And it is, I'm happy to talk a lot about it because it is one of the hardest things for providers to solve, I think. And so we're a long ways from getting it solved well. But we're incrementally getting there. It's getting easier and easier to deploy and easier to make sure that it gets deployed in a safe way. But I think it's an area where serverless lags behind traditional architectures. Thanks. So I think that's about it. Chris will come back up and tell you about lunch, which is way more important than any of the things I've talked about.